Section 2.2, Part 2, Organizing Quantitative Data. Lesson objectives. We have learned 4 from Part 1. In this session, we are going to learn 5, 6, and 7. Draw stem and leaf plots, draw dot plots, and identify the shape of a distribution. Lesson objective number 5, stem and leaf plots. A stem and leaf plot uses digits to the left of the rightmost digit to form what's called the stem. Each rightmost digit forms a leaf. For example, a data value of 147 would have 14 as the stem and 7 as a leaf. Let's look at an example. Individuals considered to be unemployed if they do not have a job but are actively seeking employment. Following data represents the unemployment rate for each of the 50 states plus DC in June of 2008. Here's the raw data. So we're going to construct a stem and leaf plot for this data. We will let the stem represent the integer portion of the number and the leaf will be the decimal portion. For example, the stem of Alabama will be 4 and the leaf will be 7. Here's our stem and leaf. These are the stems and these are the corresponding leaves. So this would be read as 2.8%. This is 3.2%, 3.2%. The largest is 8.5%. Now, what's nice about a stem and leaf is it sort of gives us a visual, and we also get to keep the raw data. So this is what the histogram would probably look like, and we can actually see the raw data. Here is the directions on how to do a stem and leaf by hand, but we're going to let Minitab and StatCrunch compute it for us. Now there's something called a split stem and leaf, and basically that's just where the stems are split in half. So for example, this corresponds 2.5 up to 2.9. This group here would be 3.0 to 3.4. This would be 3.5 to 3.9, so on and so forth. Once a frequency distribution or a histogram of continuous data is created, raw data is lost unless it's reported with the frequency distribution. However, raw data can be retrieved from a stem and leaf plot. Okay, now here's an example of a stem and leaf plot constructed in Minitab. This is using the student survey data for the early fall 09, and the variable here is age. And as we can see here, the smallest is 18, a stem of 1 and a leaf of 8. And these are all the 19s. Here we have the 20s, the 21s, the 22s, 23s, 24s. The largest would be 56. As we can see, this is a split stem and leaf. And Minitab also tells us these numbers here. I've got them in yellow because normally with most stem and leaves this is not here. But actually this tells us how many are in each category. For example, this one there's 19 here. Here there are 67, but the reason why there's parentheses here, this is where the median is, and then now it works backwards. There's one here, one person who's 56. There's two people here, a 50 and a 51, but these together make 3. So this is sort of cumulative, adding up, and it adds up to the median going this way, and then it adds up to the median going this way. Okay, here's another example of a different variable. This is distance to Cincinnati State. And we can see that the leaf is 1, therefore the stem is going to be 10 times larger than that. So for example, this would be 1 mile, this would be 1 mile, 1 mile, this would be 5 miles, that would be 10 miles, and then here is our first one. This is 10 miles, 10 miles, 10 miles, so on and so forth. So the largest is 40, second to the largest is 38 miles away. Okay, this is what a stem and leaf would look like in StatCrunch. And again, it just tells us the decimal point is 1 digit to the right of the colon. So normally this value is 10 times larger than this value. Okay, now again, what's nice about this is what the histogram would look like. Lesson objective number 6, constructing dot plots. A dot plot is drawn by placing each observation horizontally in increasing order and placing a dot above the observation for each time it's observed. Okay? For example, this is the number of available cards in a household based upon a random sample of 50 households. And this is what the dot plot would look like. Now if you remember, this is discrete data. Here very quickly we see that there are 4 households with 0 cars. There's 1 household with 5 cars. And we see the largest frequency is 2 cars per household. Let's look at another example. Okay, this is the dot plot for age. As we can see, we have a couple of 18s, and then as the ages get older, we have less and less students, and that's what we expect. We expect younger students to be in college, but we do have some older ones, but they're not as often. Most people go to college right after high school or a little bit after high school. And what a dot plot allows us to see very quickly is that it may show us that there may be potential outliers, and we'll talk more about that in chapter 3. Okay, here's a dot plot of distance away from Cincinnati State. Again, very quickly we can see which value has the largest frequency, and we can also see sort of how they are spread out. We'll talk more about that in chapter 3. Here's a dot plot for commute time given in minutes, and we can see here's a value that is very far away from the rest of the values. This is probably will be an outlier. And very quickly we can see how many observations we have for each minute. This is the same data in StatCrunch. Okay, lesson objective number 7, identify the shape of a distribution. There are going to be 4 major shapes that we identify in this class. The first one being what we call a uniform, where each of the bins are approximately the same height, the same frequency. The next one is what we call a bell shape. It is symmetric. It has 1 hump, and it's what we call bell shape. This one is what we call skew right. So if we look at the hump and we draw a line from here out to here, the tail has stretched longer to the right than it has here. So we call this skewed right. Skewed left, here's the peak, and if we were to draw from here, the tail has been stretched more than here. So this is spread out more to the left. So we call this skewed left. Let's look at some definitions. A symmetric distribution of data is symmetric if the left half of its histogram is roughly the mirror image of its right half. Skewed distribution of data is skewed if it is not symmetric and it extends to more than one side than the other. Skewed to the left is also called negatively skewed, because if things go to the left on the number line, they are going in the negative position. Skewed to the right is also known as positively skewed, and that on a number line is going to the right. To the right is positively skewed. Let's look at some pictures. If it is bell-shaped, then the mean, median, and mode are approximately the same. So if there's one peak and it is symmetric, the mean, median, and mode are about the same. We'll get more on that in chapter 3. If it is negatively skewed, then it turns out that the tail is longer, and this is going to have effect on these values. They're no longer the same. The mean actually becomes the smallest, the median is a little bit larger than that, and then the mode is the largest. We'll talk more on why that happens later on. And if it's skewed to the right or positively skewed, the mode is the smallest value, the median is a little bit larger than the mode, and then the mean is bigger than the other two. Here's the suggested readings and the suggested homework problems to try. Thanks for watching.